What's up again? This is a continuation. This is the pulsing coils and lighting LEDs part 6. I have a few other things to show you guys. Right now my pulse generator is at 20.2 megahertz. It's pulsing at 50% duty, 16.5 volts. The amperage is peanuts, totally peanuts. This little generator can't really develop that much amperage. And what I want to show you is this here. That's a little too close. Let's get a little farther out. Okay, here you can see what's being pulsed is this outer coil here, which is just lamp wire, dual lamp wire, wound around. And I have my LEDS coil here, which is the LEDS wire with the outer coil in series. That's the LED. This is my bucking coil, toroid, which is in bucking coil mode and not in go-to-lux mode. This is my other pretty trusty little coil, which is just a standard coil turned around with an LED. So you have 3 LEDs lighting up right now at the same frequency, 20.2 megahertz. And here is the most curious part. Let me just push this aside here like that. Okay, and this is how I'm pulsing this. As you can see, none of those wires are connected. None of the lamp wires, these wires here, are not connected. All I have is, I'm going to try and focus on that. I have one wire, one little coil here that's wound here, going from this side, going around, coming out here. It's going in series to this, coming back down. Now here you can notice that the coil is wound on the exterior of the insulation. On this side here, on the other wire, you can notice here the wire is coming down, being wound around, but this time I took out the insulation, wound it around directly over the conductor of the lamp wire. So, and they're receiving their pulses here. So basically what you're seeing here is 2 little coils that are on that wire. Now, one coil is on one of the wires, the other coil is on the other wire. They're not on the same wire, on this dual wire lamp wire. I'm pulsing it right there, and this is what you get here. This is something that is extremely curious as to why, if electricity is moving in a conductor, and if this obviously open-ended, electricity would move how? That's my question. How would electricity move in this? It's very hard to explain. There's no continuity. I'm not looping anything. And if I put this in a loop, it won't work. So what I'm thinking is this has to do with spin conveyance. Basically, what these 2 coils are doing are spinning the atoms inside this wire. They're just spinning them. And this spinning is concentrated in this loop here. It's creating an effect that can be picked up by these 3 different types of coils. So this is 3 totally different types of coils picking up this energy. Okay, so I'm going to stop this here, and we can go to the next one as time permits. Thank you. Okay, we're back. What I was trying to see is, with all these coils being pulsed, what would be the most common denominator of all of them? And you know, it just winds up being a north and a south field moving over a wire. And this would actually show exactly what I mean. All you have here is a wire. Not lit. Lit. Now in this case, the funniest thing is, when I look at my connection, all I have is the positive. You see here the positive of the pulse? It's being connected right there onto one of these one side of these two cables here. This is still connected with the open end. When I put the negative on here, no result. Totally off. It only works when I put the positive on here. So this is telling me that the Earth's magnetic field is probably taking up the other polarity on the off cycle. There you go again. And something else I found is with only one connection, if I just connected directly onto any one of these, it's working. But it has to be the positive. It won't work with the negative. Let me put the negative on here. Negative doesn't work. So what I'm thinking is, around this coil, we already have the Earth's magnetic field that's there. And what is happening here is, when I'm putting back the positive directly on there, I'm creating a pulse inside this coil. On the off pulse, the Earth's magnetic field is coming in and giving me the other polarity. I mean, how could this work any other way? I have an LED that's lit. I have just one side of these coils, of this coil, connected. I'm pulsing at 17.8 megahertz, 50% duty, 16.5 volts. How come I'm getting that thing to light up? I don't know if I have enough time, but what I'll do is I'm going to take this one off. Let's put this one here on. This one here is more serious. It's more serious juice required for this. And from my recollection, I put it like this. I'll play around with that. There you go. Look at that. Let me get this out. You can see that there are 9 LEDs on each one of these, and there's 2 banks that are being lit. Right now I'm at 15.5 megahertz. It's basically, there you go. How's that? Let me turn this off here. So I'm getting all this energy. It's being transferred. One wire being pulsed through this coil. And look at all that. Usually this bank of LEDs would never light up with anything below 5 volts. I'd have to have at least 5 volts to start this thing up. So I'm going to stop these here, and it's time for me to make my next build. So from this point on, I'm going to hold back on making any more of these pulsing LED videos, simply because I think I've covered quite a lot, and I'd like to put some more time into making my next build. Thank you, and have fun.